The Ralph Wiggum Loop is the most leverage you can get from AI coding right now, but most people using it don't actually understand it. They install a plugin and never learn what Ralph really is from first principles. It is so simple that once you understand why it works, you can do way more than just run someone else's setup. In this video, I'll break down what Ralph actually is, the context window trick that makes it so clever, and the 3 ways I use Ralph loops in my own work. By the end, you'll have a clear mental picture that you can actually deploy without all of the hype and confusion. I'm Roman. I published a top 3% paper at NeurIPS, the largest AI conference in the world. Now, I'm on a mission to become the best AI coder. So why do we even care about Ralph? Ralph is a method of trading tokens for mental horsepower. If you think of each LLM instance as a unit of intelligence, then you can realize that you can spawn as many as you can afford. And then, the only bottleneck left is you, which would be your attention and your time. The further out of the loop you go, the more leverage you get. But the more important your setup and planning becomes. At the very least, you can utilize autonomous agents as an exploratory tool the night before usage resets, allowing you to utilize unused tokens with no downside. And at the very best, you figure out a workflow that allows you to realize the extreme leverage potential of autonomous agents for your use case. Regardless, I highly suggest learning about and trying out autonomous agents in your own work. You will not regret it. Okay, well, I understand why it's good, but what exactly is Ralph? The Ralph Wiggum Loop is a simple bash loop that gives an agent a list of tasks until a stopping criteria is met. At each iteration, we tell the agent to study the specs and implementation plan, give the agent any repo-specific information it needs, and we tell it to pick the highest leverage task to work on, then make an unbiased unit test, and then mark completion if the test passes. This loops until the whole project is completed, whether or not you are in the loop. So as for the actual implementation, it literally is just a bash script very similar to this, which, in plain English, before stopping criteria is hit, we give the prompt to Claude in headless mode, which is what the -p is, and we loop until finished. But don't let the simplicity fool you. The planning and speccing required to make Ralph work is intense. You have to become a high-level architect. The more you put into the plan, the more you get out of Ralph. At its core, the Ralph loop is a very clever idea because it treats context windows as a static allocation problem. So traditional context trimming methods are not required. And also, just by the way, do not use the Ralph Wiggum plugin from Anthropic. It runs the loop within the same session, which causes heavy context rot and compaction. So let me explain the base idea here. If our model has a static context window that we have to carefully allocate context to in order to solve a problem, Ralph loops start with creating a spec and implementation plan upfront, and then we tell the model to choose the one highest priority task and create a unit test. So as we implement, the Ralph loop takes a little bit of context to implement its task and test, but hopefully can do it quickly and stay under the dumb zone. This is one of the core skills to getting a working Ralph loop, because the dumb zone, or around 100k tokens used in context for the Opus 4.5 model, is where the performance starts to rapidly drop. Meanwhile, in vibe coding, implementation might take you up to the context limit. This is because you don't have as clear of a picture given to Claude for what you want and how to do it. Note that most of the implementation here is done in the dumb zone, meaning people who are doing this are leaving gains on the table. So what happens next? Here's the core trick. Instead of implementing more features into the same context window, the Ralph loop chooses to update the specs and mark the subtask as complete, basically treating the implementation plan and the spec as the source of truth instead of previous context, which is typically the source of truth in general agentic coding. Meanwhile, on the vibe coding side, compaction occurred as we hit the context limit, which leaves some summarization tokens from the previous implementation in the new context. As you continue to implement more of the plan, the Ralph loop remains below the dumb zone and never has to compact, because the model can use the implementation plan and spec to get up to speed as long as they are executed and written out properly. Then we get to a point in vibe coding where all of the implementation is done in the dumb zone, resulting in a near unusable model. The summarization context begins to poison the model with irrelevant or contradictory information because it's overcompacted, and performance declines even more, which is why vibe coding causes code riddled with bugs, and I highly suggest you don't vibe code, unless if it's just for fun. So the summarization from previous implementations will continue to grow if you are not intentional about context engineering while you are vibe coding or agentic coding. So we understand what Ralph loops are and how to implement them, but how do we actually create the specs and the implementation plan? Well, the core mechanism here is that bidirectional prompting, which is where you and Claude ask each other questions until you are both on the exact same page. The reason we ask Claude questions is because it can reveal to us implicit assumptions that Claude made that would have seemed obvious to us. These assumptions are typically the root of many bugs and will be insidious as the repository grows. Since we will be out of the loop for much of the implementation while we're running Ralph loops, getting this right will result in a clear trajectory that leads to high quality code. So when you are done with the planning stage, Claude will have written both the spec and the implementation plan. The implementation plan should be done with bullet points where each bullet corresponds to a task with a checkbox beside it. This makes it super easy for each iteration of the Ralph loop to check off what it did. Then we have the important step. You must read every single line of both documents and sign off on every single line. If you don't do this, then you will not understand what the plan is and implementation will probably not go like you expected it to. So if you don't have a bulletproof plan, the errors will cascade down and are amplified in Ralph loops because you leave Ralph loops running and each iteration of a Ralph loop goes off of the previous iteration. This means that the biggest skill in Ralph loops by far is the skill of architecting a good plan. Now, what would be an example prompt.md, which if you remember from previous, is exactly the prompt that we give the model every single time. This is a very important step. So we have the specs and the implementation plan, and we must write the file, which first will tell Claude to study spec.md thoroughly, then tell it to study implementationplan.md thoroughly. Then it will pick the highest leverage unchecked task, complete the task, and then write an unbiased unit test to verify. You will also want to include context about the repository structure, conventions, etc. because remember, each loop of Ralph starts with a fresh context window, so you have to find a way to efficiently get it up to speed. Now when we trigger the bash loop, you are going to watch intently at first. Now if Ralph goes off track, the key here would be to stop it, you edit the spec, and then you restart the loop. This will teach you model behavior and gets you a more bulletproof spec for when you actually leave it running. Once Ralph looks like he's on track, you can leave and let it implement. Or you can just stay in the loop as much as you want. But kind of the whole point of Ralph is to get that autonomous loop going. Then you can come back, run all of the tests you want, end-to-end tests, you get sub-agents to build the tests, then you skim the code and decide whether to change specs and restart. You are going to have to be careful if you're using autonomous coding agents in production at your software engineering job. Probably my suggestion is you just shouldn't do it, but if you have to, you are going to need to test thoroughly and read every line of code. So even though Ralph has incredible potential as an autonomous agent, there are many downsides. The first downside is it's not token efficient, and the more Ralph loops you run in parallel, the more exponential your token use gets. The second is you trade some quality for reduced attention. So you don't have to spend as much brain power or attention sitting there watching the loop, but this trades the quality because it separates you from the actual implementation. Number 3, if your spec is too big, you risk Ralph suffering from context rot and possible compaction during implementation in every single loop, almost ensuring catastrophic failure. So it's very important to keep the spec and the implementation plan as brief as possible. Number 4, if Ralph introduces a bug or writes a bad test, it can poison the future loops and completely derail the application. And number 5, specking and expecting to know and understand all of the changes you want by just having a conversation with Claude is an extremely difficult endeavor. If you don't know exactly what you want done, I would highly suggest exploring and implementing with parallel subagents instead of using Ralph. Then what you can do is discard the code that the parallel subagents wrote, and you can take notes and begin to really figure out what you want based on that quick outcome. Here's the second way that I use Ralph loops, and I call it exploration mode. Exploration mode has nearly no downsides because it embraces the things that Ralph is good at without expecting it to be something that it's not. Sometimes I have something on the back burner, which would be something like a research task, a question, an MVP that I want to get done, or a spike for a feature. I'll spend 5 minutes brain dumping into Claude and maybe going back and forth a little bit, have Claude write the tasks and specs, and not worry too much about what they are. Then I'll launch the Ralph loop and I'll walk away, or I'll go to sleep. So I typically use exploration mode if there's something that I want to do but I don't have time for, or I use it when my max plan usage is going to reset the next day. Since you're going to lose those tokens anyways, you might as well wake up to something useful for a back burner project that kind of moves you along. Now, if you have a max plan, there's absolutely no reason not to do this. You just sandbox the model, spend 5 minutes planning, and you make sure you don't overflow into API charging by disabling that feature. So the third way I use Ralph loops is brute force testing. You are going to start on the security side, for example. You would maybe have Ralph systematically try every single attack vector that you can think of. There are ways to store this so that you know all of the attack vectors that you want looked at every single time you build an application. And on the UI side, you might test every user-facing action in your application. This would be login flows, checkout, search, forms, every path a user could take. The way you do this is you give Claude access to a browser. It can go through the browser on your site and do all of the end-to-end tests you want, which typically the end-to-end tests would take a very long time, but the Ralph loop works through each and every case in a brute force manner and will save you time by you not having to test these yourself. It can do it overnight while you sleep, and you might want to give him a sandboxed environment to let him find every bug and edge case in your app. Now, this is just scratching the surface. Notice that things like Claude Code and loops like the Ralph loop are basically just wrappers for the LLM architecture that take advantage of the fact that LLMs are a method of offloading intelligence for the price of tokens or energy. This means that we can parallelize very aggressively, especially as tokens start to get cheaper, and scale our output, but not just scale our output, scale the amount of intelligence or thinking that goes into an application. So the longer you have LLMs working, and the more you have them thinking of what they could possibly do, the better. If you have gotten this far in the video and you enjoyed it, I really would appreciate it if you subscribe, and you can go ahead and join my free school community for some nice free resources. Thank you for watching, and I'll see you in the next one.